Well, I don't know if you can believe it, but this is pretty amazing. We are halfway done with Calculus AB. So today is our first day. We're going to begin integration, and I'm going to do quite a few examples, so stick with me. I'll try to change each example slightly. But let's just title this Basic Integration Rules. So you're probably thinking, what is integration? Well, here's the definition we want to put in our book. Integration is the process of finding the antiderivative or indefinite integral. Integration is the reverse of differentiation. So first of all, I want to be very clear that integration and antiderivative are equivalent. Okay, if I take an integral or I antiderive, I'm doing the same thing. So those words will be used interchangeably. Now, you can think of it as kind of like a derivative moves forward, and your integral does the opposite. The integral is like going backwards. Okay, so they're kind of undoing each other if you did them at the same time. Think of the derivative as going forward and the integral going backwards. So here's a great question to start with. Who do I take the derivative of to get 5x to the fourth? My guess is you can come up with that pretty quickly off the top of your head. Who are you going to take the derivative of? So the derivative of who equals 5x to the fourth. And again, I'm hoping by now you've kind of said x to the fifth is your answer. And if you did, you've just integrated. You've worked backwards. So again, I want you to title this next little section called Indefinite Integrals. We're going to deal with two types of integrals this year, indefinite and definite. So we'll start with the indefinite integral. First of all, this symbol that you see here, okay, is the symbol for integration, also known as an integral. The differential, usually dx, dy, d theta, or dt, indicates the variable of the integral. For example, if you saw the integral symbol and you saw, let's say, sine of theta, right next to it would have to be d theta. And what that means is this variable is telling you the variable we're going to integrate. Or if I said integrate x squared, I would have to have a dx, x being the variable we're going to integrate. Hopefully you get the idea. If I said y cubed, I'd have to have a dy. And again, this is just telling me the variable we're going to integrate. So first example here, it says we're going to integrate this function. So I would say this is the integral, and I would wrap that in parentheses, x squared minus 4x. So this is who I'm integrating. And I would just slap a dx there to let the reader know that I'm integrating with respect to x. So we're going to go ahead and start with some basic integration rules. Okay, rule number 1. The integral of k dx is equal to kx plus c. So let's talk about what this rule is saying. Notice the dx here. That means I'm integrating with respect to x, but I don't have an x in my problem. So what's that implying is that k is a constant. Okay, so keep in mind k is a constant. So let me give you a quick example. What if I said, let's integrate 7 dx? What would my answer be? So again, I'm saying, who am I taking the derivative of to get 7? Now, my bet is every single one of us have come up with a different answer. Okay, maybe some of you just said 7x. But is that the only answer? Yes, the derivative of 7x is 7, but could you give me another answer? How about 7x plus 5? Is its derivative 7? Or 7x minus 10? Or 7x plus pi? Remember, pi is a constant. Or 7x minus 55. All of these answers are answers to the integral of 7. So what we do, instead of listing out every possible one, which would be obviously impossible, we slap on this plus c, meaning we are going to get 7 times x plus any number in the world. And that c could be a negative number, so we just say plus c, meaning c could be any number. So what that's called is the general solution. All right, and you're going to hear me refer to the words general solution pretty often. So when I integrate k dx, I get my kx plus c. When I stick that plus c on, I'm implying we just get a general solution. It could be anything in the form of this. Moving on to example 2. The integral of x to the n dx is equal to x to the n plus 1 divided by n plus 1 plus c. Now, I know that seems intimidating, and probably so did taking the derivative for the first time. Keep this in mind. When you take a derivative, what do you do to your exponent? You subtract 1. Now, if you're going to integrate, you're going the other way. So instead of subtracting 1, we're actually going to add 1. Okay, so I would take my x to the n, I'm going to add 1, and then I'm going to divide by whatever that number is. Okay, and of course, I'm going to get a general solution of a plus c. Okay, so all indefinite integrals have this nice plus c on the end, meaning there is an infinite amount of answers. Okay, again, that means there is an infinite amount of answers. And that's what I was trying to show you over here. Hopefully you got the gist of that. All right, so we're going to go through, like I said, a bunch of different examples. First example, let's integrate 5 with respect to x. So again, in your head, you're saying, who do I take the derivative of to get 5? And that answer is 5x plus any number in the world, plus or minus, so we just say plus c. Number 2, this is similar to that second integration rule we just talked about. Okay, if I were to take the derivative, I would subtract 1, but I'm integrating, so I'm going to add 1. So I'm going to say this is x to the, I want to add 1, so that's x to the 5th, and now you divide by that same number. So this is x to the 5th over 5 plus c. All right, we have more integral rules. The next one is called a scalar multiple. And basically what happens is you have some constant times a function. All right, so let's jot this down. It's the integral of k times f of x dx. And all we're going to do is we're going to pull the constant out front and integrate f of x. And then our second rule is you are allowed to split integrals for addition or subtraction. So if I had function f of x plus g of x, I can integrate function f of x and then add to it function g of x. So you are allowed to split simply for addition or subtraction. So again, let's run through some of these properties. Number 1, notice I have a multiple in front. Here's what that rule was saying. You can pull out the negative 2 and just integrate x cubed dx. Okay, so just like in derivatives, we rewrote things, we're going to rewrite things in integral. So I'm pulling out the negative 2 because I was multiplying, and I'll just leave the negative 2 coming along for the ride, and now we'll integrate x cubed. Remember, add 1 and then divide by that number. So when I clean that up, let's see, negative 2 and 4, that goes in there once, so I get a negative x to the 4th over 2 plus c. Okay, pause it when you need to. Number 2, the integral of x to the 5th plus x dx. Now remember, just going to wrap that in parentheses. The rule said if you're adding, you can split these integrals if you want. You can say it's the integral of x to the 5th plus the integral of x. Whoops, each one gets a dx. Now we'll simply integrate. The integral of x to the 5th is, remember, add x to the 6 over 6 plus the integral that's x to the 1st, that's going to be x squared over 2. And then don't forget the plus c. Now you don't have to put a plus c on each one, we're just going to put a plus c on the final answer. Alright, so like I said, we're going to do a lot of practice tonight, and just stick with me on these. So question 3, the integral of 1 over x cubed. Now, we don't have a rule for a fraction, so we need to rewrite it. And like I said, just like a derivative, there's a lot of rewriting involved. How can you rewrite 1 over x cubed? Well, hopefully your gut says x to the negative 3rd dx. Okay, and again, this dx is just saying I'm taking the integral with respect to x, and now just apply the rule. Add 1. Be smart. Negative 3 plus 1 is actually negative 2, and then divided by that same number, plus c. Now, we always want to clean it up without, negative exponents. So let's put it back to its regular form. Because this 2 is on the bottom, we want to rewrite it, of course, as negative 1/2, and that x squared goes downstairs, plus c. Okay, and again, I'm not doing anything fancy. This 2 is on the bottom, makes it a half. This comes downstairs. Number 4, the integral of 5 radical x. So again, watch how I slow down and rewrite. This is being a multiple, it's a scalar multiple, so it can come out front. The integral of x to the what power? Okay, nice 1/2 there. Now remember, you're adding 1. So when I think of 1, I'm going to say that's really 2 over 2. So I get x to the 3/2. Okay, now you can say divided by 3/2, but I think we can be smarter than that. dividing by a fraction is the same as multiplying by its reciprocal. So I'm actually going to say times 2/3. Okay, now don't forget you have that 5 out front. So I actually get, that's 5 over 1, so I get 10/3 x to the 3/2 plus c. Okay, so let me say that again. Dividing by a fraction is the exact same thing as multiplying by its reciprocal. So anytime I have a fraction here and I'm supposed to divide by it, I'm going to multiply by its reciprocal instead. Number 5, the integral of the quantity x squared plus 1 squared. Now we have no chain rule in integration, okay, so you really have to clean these up. So I'm going to first rewrite this as the integral, and of course squared just means write it down twice in FOIL. So x squared times x squared is x to the 4th, plus x squared plus x squared, so that's 2x squared plus 1. Oops. Okay, so again, I need to slow down and FOIL. All right, let's put a big note in our book there. There is no product rule, no chain rule, nothing like that for integrals. Now we have a nice simple integral. If you really want, you could split each of these up. It's not necessary, but if you wanted to, you could say it's the integral of x to the 5th plus the integral, I could pull that 2 out, x squared, plus the integral of 1 dx. And obviously all those get dx's. But you can just integrate each one as you go. So I'm going to say this is x to the 5th over 5, plus when I add 1, I'm going to get x to the 3rd, pen's dying here, over 3, and that's still times 2, plus, who do you take the derivative of to get 1? Well, that's just plain old x plus c. Now remember, it's real easy to check and see if you're right. Just take what you integrated and quickly take its derivative. Well, the derivative of a constant is 0. The derivative of x is 1. The derivative of 2x cubed over 3, if I bring that down, I get 6/3, which is 2x squared. And if I bring my 5 down, those 5's cancel and I get x to the 4th. All right, question 6. Now, I know some of you are probably thinking product rule, quotient rule, but we don't have those rules for integrating yet. Okay, and we're probably not going to for the most part. What we want to do is practice rewriting. All right, so here's what I'm saying to myself. When I see that one term on the bottom, whether or not you like splitting or not, it's pretty much our only option right now. We need to make like a beaver and split. All right, so let's do it nice and slow. I'm just going to take x and I'm going to divide it by, instead of saying radical x, of course I'm going to say x to the 1/2 plus 1 divided by x to the 1/2 dx. Okay, I've done zero calculus, just some basic algebra. Now I'm going to go a step further and keep cleaning that up. X to the 1st divided by x to the 1/2, well remember you subtract exponents when you divide, so that's really just x to the 1/2. Plus, this bear I can just rewrite, I can simply move that up to the top by saying x to the negative 1/2 dx. Now I'll integrate. Okay, remember we're going to add 1 instead of subtract 1, so I'm going to add 1, which is 2 over 2, so I get x to the 3/2. And instead of saying divided by 3/2, multiply by the reciprocal, so times 2/3. Okay, I've got my plus sign. X, I'm going to add 1, so I'm going to add 2 over 2, so that's x to the 1/2. And again, instead of dividing by 1/2, I'm going to multiply by the reciprocal, which is 2. And then don't forget your plus c. Hopefully you're starting to feel pretty good about these. Let's keep chugging. Number 7. So I've got the integral of 1 over 7x cubed plus 3 radical x plus 2 over radical x dx. Now again, I'm not going to integrate right off the bat. Let's rewrite this. You actually have what fraction here? All right, I'm going to say that's 1/7, and then I'm going to call this x to the negative 3rd. All right, pull those fractions out. Plus, this is really x to the 1/3. Plus, I'm going to bring that upstairs, so I get 2x to the negative 1/2 dx. All right, now that I've rewritten everybody to a power, now we'll integrate. Remember, we're adding 1. Okay, so if I add 1, I get x to the negative 2. It's a whole number, so I'm going to say divided by negative 2. And I'm just going to leave that 1/7 out front. Plus x to the add 1, so that's 3/3, so I get x to the 4/3. And instead of saying divided by 4/3, we're going to multiply by 3/4. Plus, I'm going to leave that 2 there. X raised to the add 2 over 2, that gets me 1/2. And instead of dividing by a half, multiply by 2. And then don't forget your plus c. Lastly, we'll just go through and clean each one of those up. We're not going to leave any negative exponents. So I'm going to get a negative 1 over 14. And this x squared moves downstairs. plus, this is 3/4, and I'm going to say that's the cubed root of x to the 4th, plus 2 times 2 is 4, and that's the square root of x, plus c. And number 8 here, we're going to integrate x cubed plus x squared minus 7 divided by 5x squared dx. All right, so I can't stress the rewriting step is so very important. All right, so let's just slow down and rewrite. Now remember, we've got to make like a beaver and split, and we're just dividing every term by 5x squared. And I'll go through it nice and slow again. Just rewrite every term by 5x squared if you can't do it in your head. Whoa, did I write? That should just be squared. So I've got x squared over 5x squared minus 7 over 5x squared dx. Okay, and again, this is not calculus, this is just a simple rewriting, and we're going to rewrite again just to clean it up. Now, remind yourself, this 5 is on the bottom, so that's actually 1/5 x, plus this 5 is on the bottom, so that's just 1/5, those cancel, minus, this is 7/5, and I'll have to rewrite that as x to the negative 2 dx. All right, now we're finally ready to integrate. Now remember, you're adding 1. So I get x to the 2nd divided by 2, and of course times that 5th, plus, who do you take the derivative of to get 1/5 as an answer? Well, that's just 1/5 x. And again, if you're not sure, once you do it, take its derivative and see if it matches. And then when I add 1 here, I'm going to get x to the negative 1 divided by negative 1, and don't forget you already have times a negative 7/5, and that famous plus c. Lastly, we'll just clean it up. I actually get 1/10 x squared plus 1/5 x. Let's see. This is going to make this a positive 7/5, and this x to the negative 1 just moves downstairs, and then a plus c on the end. Well, we're tugging. We've made it to the last 2 examples for the night. And again, I'm just going to stress that rewriting step. Number 9, what does your gut tell you to do with this x hanging out here? Hopefully it's just saying quickly rewrite it. So I'm just going to rewrite this as 2x to the 4th when I multiply, minus 7x cubed plus 3x squared plus 4x dx. Okay, and again, I just want to stress that dx is just telling you that should be the variable in my problem. So at this point, I'm sure you can pause it, integrate it, and see if our answers are the same. So hopefully you can see what I've got. And again, if you're ever uncertain, just take your answer's derivative and it should match the integral. The derivative of 2x squared, 4x, 3x cubed, minus 7x cubed, and that should be 2x to the 5th. All right, last question for the evening. Again, I want to stress that rewriting step. And you'll notice you'll see m's in this one, and then it says dm at the end. So again, this is just stressing the variable that you are integrating. All right, so I'm going to get m to the 1/2 plus m to the 2/3. Be smart on this one. I'm going to rewrite that as 1/3 m to the negative 1/2 plus 2m to the negative 3rd. If you can rewrite that correctly, the integral part should be nice and easy. And again, I want you to pause it and see what you get. Well, welcome back. Hopefully that integral matches mine, and you can kind of go through and check out my work on your own there. Again, make sure you add 1, and don't forget that plus c on the end. It's so important because there is an infinite amount of answers with this integral. Well, that does it tonight for basic integration rules. Hopefully you had as much fun as I did, and I'll look forward to seeing you tomorrow.